So the very first thing that you should do, a lot of students mistakenly think that this x squared and this x squared will cancel. Is that true? The fact that I said mistakenly should have been a clue. So it is not true. It does not work that way. The only time, the first step that you have to follow when you're simplifying rational expressions is to factor the numerator and denominator completely. Okay, so you can't cancel until you've factored everything completely. All right, so for this particular example, the first step, now, as you go through this step, pay careful attention to the type of factors you're dealing with. Are you dealing with monomial factors or binomial factors or so on? Because when you get to the step of canceling, you can only cancel factors that have the same number of terms. And so our numerator, there's nothing to do with it. It's just a monomial factor, so we leave it as it is. But in our denominator, is there a common factor we can remove from those two terms? Yeah, we take out our common factor of x. Okay, the remaining expression has to have the exact same form as the original. It has to have two terms. So it has to be a binomial. When we take an x out of our first term, we're left with an x. When we take an x out of our second term, we're left with a negative 1. Okay, so this is step 1. We factor the numerator and denominator completely. Once you complete this step, then you can factor any common factors. I'm sorry, you can cancel any common factors. And notice that these have to have the same number of terms. So when we look here to cancel, we can only cancel monomial factors with monomial factors, or binomial factors with binomial factors that are exactly the same. And so when we look here, we have a monomial factor of x in the denominator. The x factors in the numerator is part of the monomial, so we can cancel that. So the x in the denominator cancels with one of these x's. That's the only canceling that can occur here, so we're left with our expression 3x over x minus 1. And now, here's where things might differ from what you have been exposed to in the past. So what you guys very likely did was you would write your expression 3x over x minus 1, and then you'd identify that x cannot equal 1. Correct? Is that a restriction based on this expression? Yeah. In this case, what we're going to do in this year is instead of identifying the domain restrictions that you can see, we're going to go back and look at any domain restrictions that had to be present from the original form but are no longer apparent from the simplified form. So what we're going to do is we're going to identify domain restrictions. That are not apparent from the simplified form. And basically what we're looking for here we're looking at factors that got canceled from the denominator. All right, so if we go back in and we see we had two factors in our denominator. Okay, the x minus 1 stays. So we already can see x can't be a 1. It's redundant. You don't need to write that. But what we don't see is based on this original form, x couldn't have been a 0 either. That restriction is not apparent in the simplified form. So we need to exclude that value of x from the entire expression, even in its simplified form. Okay, so you need to go back in and find through the work of the problem any factors that were canceled completely from the denominator. Make sure those domain restrictions are identified either in the form of the simplified answer or you explicitly restrict them after the simplified expression. All right, let's take a look at a couple other examples here. All right, see if you can simplify this expression for me, please. Right? So when you look at this, factor the numerator and denominator completely. They're both monomial factors. There's nothing that we need to adjust on that. Cancel any common factor. So this monomial factor of x cancels with one of the factors from the numerator, leaving us with just a 5x. Okay, and now we look to see, were there any factors that got canceled from the denominator? Yes? So what value of x would give us division by 0? 0. So we have to exclude that value. So this domain restriction is not apparent from the simplified form, so we have to state it separately. And now let's compare this to a similar problem. All right, see if you can factor this expression, please. All right, once again, there's no factoring necessary. That's just two monomial factors. Cancel the common factor. This x from the numerator cancels with one of these x's from the denominator, leaving the expression 5 over x. All right, so were there any factors canceled completely from the denominator? We canceled this x, but is there still an x? Yeah, so even though we see here this factor was canceled, so we know x can't be 0, is that restriction shown in our simplified form? Yeah, you see right here, 5 over x, you can see x not equal to 0, so there's no additional domain restrictions that are necessary. If I asked you this on a homework problem, you would write in the space for the additional domain restrictions, you would write none. It doesn't mean that there's no restrictions, and because you can still see x is not equal to 0, but that's the only one, and that one is apparent from this simplified form. All right, listen. Let's do one last example here. All right, see if you can simplify this expression, please. All right, when you're looking to perform step 1, the factor, which of these expressions is going to be easier to factor, the numerator or denominator? Probably the numerator, right? So if you start by factoring the easier one, so in this case we have a common factor of 5, leaving an x plus 2. What that will often do is it'll often give you a hint as to what one of the other factors of the more complicated one will likely be. Again, it's not a guarantee, but most likely, since we are canceling common factors and simplifying here, it's very likely that x plus 2 is going to be a factor of this expression. Like I said, it's not a guarantee, but as far as the trial and error part goes, not a bad way to test it. So let's assume that x plus 2 is one of our factors. We know that this bottom factor has to have the following values. The first terms have to have a product of 4x squared. So what times x gives you a 4x squared? So let's test this in trial and error. And then we see our last terms have to, or the last product of the last terms has to be negative 2. So what can we multiply by positive 2 to get a negative 2? Negative 1. So let's test this by trial and error and see if our outer plus inner products is equal to plus 7x. So outer product is 4x times 2 is 8x. Our inner product, negative x times 1, is 8x minus 1x equal to plus 7x. Yeah, so it fits. It's often a good idea and very efficient to use this method. Factor the easier one first, the simpler expression first, and then see if that set of factors will help you in trial and error process. Okay, once we have it completely factored, we can now cancel our common factors. We have two binomial factors that are exactly the same. Again, that's the only way that those factors can be canceled, is if they're the exact same number of terms and the exact same terms. So we're left with 5 over 4x minus 1. Okay, and when we look at the factors that got canceled from our denominators, we can see here that x can't be what? Negative 2. Is that apparent in our simplified form? No, so we need to exclude that on our own. And so that would be our domain exclusion. All right, let's do one more example here. Let's see if you can simplify the following expression, please. All right, so when we're looking at this, the numerator is already a binomial factor. There's nothing else we can do to it. Hey, what about the denominator? Any common factors we can remove from this? If you go back to what I had recommended, anytime you're writing factors, my recommendation is write them in standard form and write them with, when you write your factors, especially binomial, trinomial factors, write them with a leading coefficient that's positive. So instead of thinking of it in the form that it was given, if you reorder the terms, so negative 2x squared plus 6x, so that's just, again, reordering the terms. And then take out a factor so that our binomial that remains will be positive. We can take out a negative 2x as a common factor. That leaves an x and a negative 3. And by doing it this way, what you're able to see here is that these binomial factors of x minus 3 can cancel. We're left with 1 over negative 2x. Anytime you have a negative, go ahead and move it up to the numerator. And so here would be your expression. If we look and see, are there any common factors that were canceled from our denominator? We see here that the x minus 3 was canceled, so what additional restriction do we have to account for? X can't be a 3.